Lesson 1 of Chapter 10 is on sequences, series, and sigma notation. We're going to break this into 3 different days, but our first day we're just going to focus on sequences. So a sequence is simply a list of numbers, like you can see here. This problem says find the next 4 terms of the sequence. So you have to look and try to find the pattern. Well, this particular pattern you can see is just increasing by 5 each time. So the next 4 terms would be 22, 27, 32, and 37. Next one is the same directions. Find the next 4 terms of this sequence. This pattern, though, is a little bit different. It's not a common difference. It doesn't go up by 5 each time. You can see the first 2 numbers increases by 3, then it increases by 5, then it increases by 7. So we'd have to increase by 9 to get 26, then we'd have to increase by 11 to get 37, then we need to increase by 13 to get 50, and then increase by 15 to get 65. Sometimes they'll ask you to find the first 4 terms of a sequence, and they'll give you a formula. So with this formula, you can find your first term by putting 1 in for n. And so it looks like we get -2 for our first term. We can find our second term by putting 2 in for n. And that would give us +4. We can find our third term by putting 3 in for n. And that would give us -6. And then we can find our fourth term by putting 4 in for n. And that would give us +8. So each sequence can be unique and different. Here's another similar example. It says find the first 4 terms of this sequence, and it gives us a formula. So again, to find our first term, we're going to put 1 in for n, and that's going to give us -9. To find the second term, we're going to put 2 in for n, and that's going to give us -2. Find the third term, we'll put 3 in for n. That will give us 17. And then to find the fourth term, put 4 in for n. And that gives us 54. So basically we're just building a sequence here based upon the formula. Next thing I want to talk about is subscript. As you saw in my last couple of examples, I used subscripts to represent first term, second term, third term, so on and so forth. Well, eventually you'd get to what we call the nth term, which I would write like this. Now the term that comes after the nth term would be a subscript n plus 1. The term that would come after that is the n plus 2 term. So then if I were to ask you what term would come right before the nth term, the answer would be the n minus 1 term. So using subscripts to represent a particular term is going to be important as we use what's called recursive definitions. Okay, so this formula is going to be a little bit different than the ones I showed you in the previous examples. The directions here says find the 6th term of each sequence. It gives us the first term as 3, and then this formula right here is an explicit formula. Sorry, it's a recursive formula, which means you have to use the previous term. Okay, so we're going to start off by finding the second term by using the first term. So if we take -2 times the first term, that would give us -6. Now to find the third term, we're going to take -2 times the second term, and that would give us +12. Now to find the fourth term, we'll take -2 times the third term, and that would give us -24. Fifth term would be -2 times the fourth term, which would give us +48. And then our sixth term would be -2 times our fifth term, which would be negative 96. So this is a recursive definition. A lot of people get really confused about this right here, n is greater than or equal to 2. That simply means you have to start off finding the second term or greater than that. Here's another similar example. The directions say find the sixth term. Find the sixth term. You can see that they're giving us the first term, and then they're giving us right here a formula. It's a recursive formula. You have to use the previous term to find the next term, and we have to start off by finding the second term. So the formula says to find the second term, we're going to take 2 times the previous term and then subtract 7. So 2 times 8 is 16. 16 minus 7 gives us a 9. To find the third term, we're going to take 2 times the second term and then subtract 7. So 2 times 9 is 18. 18 minus 7 gives us 11. And we have to find the fourth term by taking 2 times the third term and then subtracting 7. So 2 times 11 is 22. 22 minus 7 gives us 15. Then to find the fifth term, we're going to take 2 times the fourth term, then subtract 7. So 2 times 15 is 30. 30 minus 7 gives us 23. And then to find our sixth term, we're going to take 2 times the fifth term, and then subtract 7. So 2 times 23 is 46. 46 minus 7 gives us 39. My last example is kind of a hybrid between a recursive definition and an explicit one. This says to find the fifth term of the recursive sequence. You can see that they're giving us the first term, and then here is the recursive definition. What's unique about it is, like I said, it's a hybrid between a recursive and an explicit definition. So we're going to find our second term. How do I know that? Again, pay attention to this. And to find our second term, we're going to have to take our first term and then add 2 times 2 minus 1. Well, since our first term is 1, it's going to be 1 plus 4 minus 1, which gives us 4. So that's our second term. To find our third term, we're going to take the previous term, the second term, add 2 times 3, and then minus 1. So 4 plus 6 minus 1 gives us 9. To find the fourth term, we're going to take the previous term. We're going to add 2 times 4, subtract 1. So 9 plus 8 minus 1 would give us 16. And now to find our fifth term, we'll take the previous term, the fourth term. We'll add 2 times 5, subtract 1. This would give us 16 plus 10 minus 1, which is 25. So the other day I was walking down the street and I happened to notice a couple of parallel lines, and I was thinking to myself that, you know, they've got so much in common, it's a shame they'll never meet.